All right, this is the last video for Unit 1 of Algebra 2, Lesson 9. So we are wrapping up this unit and we'll be doing review next week. So we're going to look at functions in this lesson, and that should be a concept that's familiar to you. Basically, we're going to talk through some vocabulary first. First concept is this idea of relations and functions. And so what you need to understand is that a relation is any connected values, or it could even be objects or things like that. Just it's a relationship. I mean, it's kind of self-explanatory. But a relation is usually represented in math as a list of ordered pairs. Like something like that. So this would be a relation. So the thing about relations is they don't have to have necessarily a rule or any kind of reason for these different numbers to be connected. 1 and 3, 2 and 7, 3 and 8, 2 and negative 3. And that is what differentiates relations from functions. Functions, we often say, are 1, 2, 1. Meaning that unlike this relation up here, each number in the first part of the expression always leads me to whatever's in the second. In other words, I would never see a repeating value in the first part of each of these ordered pairs. Here you can see we have a repeating 2. There are two 2's. They appear twice. 2 could create a 7. 2 could make a negative 3. That is not allowable in a function. A function is always 1 to 1, which means every x value always leads to the same y value. And I kind of introduced a new concept there, but one thing we have to understand about functions is we have what we call the domain, and we have the range. And each ordered pair, also known as the x and the y, each ordered pair is one part of the domain and one part of the range. And it's 1 to 1 in the sense that each domain value, each x value, always leads to the same y value. There are never going to be any repeating x values because the function needs to be predictable. In a relation like the one we have up here, 2 could go to 7 or 2 could go to negative 3. We don't know. But down here, 2 always goes to 6. So that is one major concept that you have to understand, is the difference between relations and functions. Now, relations include all ordered pair sets. So functions are relations, but they are a unique type of relation where there is a 1-to-1 relationship. So that's kind of a summary of what you see here at the top. I've also talked about the domain and range. The domain and range. Domain is also known as the x. Another way of thinking it is the domain is the input and the range is the output. These are all ideas that are connected to domain and range. So the domain is where we start, the x, the input, and the range is the output or the y value. All right. So let's talk through kind of some of the things they ask us about. And I might have to jump back and forth. And that's okay. So let's talk about how, first things first, vocabulary. A blank is a set of ordered pairs. The set of first coordinates of each ordered pair in a relation is the domain, range, relation, function. What is it? So this is all vocabulary. I've already gone over those vocabulary words, actually. So we're going to just go down through that. Also vocabulary number 5. Then starting at number 6, they ask us a few questions about some sets. It's just 3 different sets as to whether or not they are relations, functions, or neither. I will tell you right now, the answer is never neither. All of these are relations, automatically relations. Every set of ordered pairs is a relation. But what you have to decide is whether or not those sets are functions. And I'll remind you, the way you know it's a function is if it is 1 to 1, meaning there is no repeating x value. So you need to make sure there are no repeating x values in these functions or in these relations, and that would mean you could check the box for function, for instance. But I'll tell you right now, they are all relations because all sets of ordered pairs are relations. Okay, so that is what a function is and how it functions. So the next concept they introduce is called inverse. So an inverse, hopefully that's also a familiar term for you. An inverse is what happens when we take the x values and the y values, or the domain and the range, and we switch them. And we find the function that is the exact opposite of another function. So I'm going to go through a few examples of how we do this. And I'll tell you the two main steps that you do is you switch x and y, and then you solve for y again. That's it. That's the step for every single inverse function problem. So they're going to give you a function in an equation form, and you're going to have to find the inverse. So let's start with an example. Let's say we have y equals 2x plus 7. Okay, first step, switch x and y. Let me do a different color on that one. So let's switch x and y, giving me a new function, x equals 2y plus 7. Then it says to solve for y. In other words, I need to now get y to be by itself. So I need to get rid of everything over here. So we are going to start by doing basic algebra. So this should be nothing new to you. We're going to subtract 7 from both sides. That's going to cancel that out, leaving me with x minus 7 equals 2y. Then we're going to divide by 2 to get rid of this 2, leaving me with y equals x minus 7 over 2. And that would be the inverse of the function we had earlier. So you can see we switched the x and the y, then we solved for y again, and we ended up with this function x minus 7 divided by 2. And if you go and look back at the original, you can see that we had 2 times x. Well, now I have divided by 2, which is the opposite of multiplication. I started with plus 7. Now I have minus 7. So your inverse should contain all the opposites of the original function. Let's look at another example. Let's look at one that has a squared in it, because I think at least one of your examples has that. Yeah. Let's do one that has squared. So let's say we had y equals 3x squared plus, or let's do minus 4. Okay. First step, switch x and y. X equals 3y squared minus 4. Notice I didn't bring this with me. I left it. I just literally exchanged the x and the y. Now I solve. Solve for y. First things first, I need to move 4 plus 4 plus 4. This is all basic algebra stuff. X plus 4 equals 3y squared. Okay, I need to keep going. I see there's a 3 being multiplied by y, so I'm going to divide both sides by 3, leaving me with x plus 4 divided by 3 equals y squared. Okay, how do I get rid of squared? To get rid of squared, I have to do the square root, which is the opposite of squaring something. And that gives me the square root of x plus 4 divided by 3 equals y. And that would be the inverse. So there's a couple examples. Those examples I just did are going to be pretty much exactly what you see in number 9 and number 10, just different numbers. So you just solve by doing the opposite. Remember, switch x and y, solve for y again. Number 10 is very simple, one step. All right, I won't spend a lot of time on this, but there is a way to test whether or not something is a function by looking at the graph. And quite simply, if you can draw a line through the graph that's a vertical line and it touches the graph twice, then it is not a function. Functions only have one touch vertical lines. So this would be a function. So again, I'm not going to talk more about that. Use the vertical line test. Draw a vertical line until you see whether or not it touches that graph more than one place. That's what you're doing in number 12. That's what you're doing in number 13. If you can draw a line, a vertical line that touches the graph twice, then you've broken the rule. You do not have a function. So touching twice means no. Touching twice means no. And I think that there is a kind of a summary of that up here. Right here, the vertical line test is somewhere up here. And of course, I'm not finding it now. But anyways, if a line touches twice, it is not a function. I will put a summary of that in the notes so you have that in front of you when you go to do the work. Then we get to number 14 and it asks us about the domain. So they give us this notation here, and I just want to make sure you understand how this notation works. The lower number, the first number, is the low end or the farthest down that function goes, and the second one is the farthest up. And when I say up and down, I actually mean in terms of the x, because if you remember, the domain is x and the range is y. So let's graph this function and let's talk about it. So 3x squared. Let's go here. We'll do 3x squared. There's my graph. So the question becomes, what is the domain? Okay, what is the domain? Now, the domain is always going to be dealing with the x, so we're dealing with how far the graph goes to the left and to the right. And it may appear at first that this graph stops, maybe perhaps there, but you could continue to zoom out. It's important that you understand that. I could continue to zoom out of this and see that this graph continues to go. Now, it also looks like maybe it might not go very, oh, and I messed up my scale, so let's try to fix that. Oh, man. There we go. There we go. All right, let's fix that. There we go. So it may appear at first that this doesn't go past this point, but it does. In fact, it continues to go in either direction. And also in your lesson, they have a brief discussion of this. They talk about the fact that with quadratic functions, like this one right here, the domain has this inequality notation or this interval notation. So tell you right now, the domain of all of the functions that we're dealing with in this lesson is, as you can see, positive and negative infinity with a parentheses around it. So that's kind of a key piece of information. So I'm telling you right now that if they ask you about the domain on any of these functions, they are going to be asking you to find the one where there is positive and negative infinity bound by parentheses. Now, what about range? Okay, so let's graph this function. Negative 4 to the x plus 7. What was that? Negative 4 raised to the x power plus 7. All right. Here's the function right there. All right. Now, this side pretty clearly goes on forever. But this, you can see it's very clear. There is a line right here that is not going to pass. And if I were to zoom out, let me erase all my lines. If I were to zoom out and zoom out and zoom out and zoom out, you can see this one, even though it's only increasing a little by little, it does continue to go over. Whereas this one stays straight across. It does not increase beyond that number, which let's go see what number that is. Yes, it's 7. So we can see that is going to 7, not crossing it. So that means the range doesn't go beyond 7. It keeps going down, but it doesn't go beyond 7. So let's see if we can find that in our list. Well, that has negative 4. That has negative 4. That has 0. So we've got to be dealing with one of these. The question just becomes, is it the x that's greater than 7, or is it the y that's less than 7? And since we are dealing with the range, we should be knowing right away that we're doing that one. So I'll let you use the same concept that I just went over to answer number 16. Number 17, using the function y equals 8,000 times 1.04 raised to the x, the following table displays the initial and ending balance of a stock fund. What of the following pairs are the domain and range of the situation? Question: what do I do with domain and range when it is in a table like this? Well, you need to think of the first part of the table as the x, the second part of the table is the y. In other words, the years are the domain, and the account balance is the range. Also, these are going to be bound by brackets because 0 and 10 are part of the value, and 8,000 and 11,842 are also parts of the value. So you need to find the domain and range down here that has these values bound with brackets. So I think you can figure that one out. Not too much complication there. They try to throw you off, but if you look at it closely, I think you'll see. And also, don't worry about any of these symbols over here. You just need to find the one that has these values bound by brackets. So that is the end of lesson 9. And we will be doing review next week. So good work, everybody. Reach out to me if you have questions.